Alrighty, folks. What we're going to talk about in this session is we're going to talk about a technique called partial fraction decomposition. Now, this is a technique that is useful when dealing with rational expressions. And since we're dealing with rational expressions in class right now, it's appropriate to learn about partial fraction decomposition. And basically what you're doing with partial fraction decomposition is you are breaking down, it's almost like the opposite of adding rational expressions. So adding rational expressions, you find a common denominator and put them together. In partial fraction decomposition, you are taking the fractions apart and or taking the fraction apart by addition or subtraction and causing it to not have a common denominator. So let me give you an example here. Let's say that we have 4 over x squared plus 8x plus 15. Okay, so here's a rational expression. Now, it is very important that you understand the first requirement for partial fraction decomposition is that the denominator must be factorable. If the denominator is not factorable, it may not qualify for partial fraction decomposition. Okay, but here's the basic idea. The very first thing that you want to do in partial fraction decomposition is you want to factor the denominator. Okay, factor the denominator. So we're going to factor this denominator. This is now going to become 4 over, and if you see here, this is a product sum factoring situation. Two numbers that multiply to 15 but add up to 8 are positive 3 and positive 5. So this is going to become x plus 3 times x plus 5. Okay? The next step is to basically give each of the factors. Now, it can get a little more complicated with more complicated rational expressions, but you're basically going to give each of the factors their own fraction. Okay? So, separate factors in denominator into their own fractions by addition, meaning you're going to separate them by addition. You're going to put a plus sign in between them. Okay, so what we're going to do is and then also there's a second part to that. So we're going to put a fraction line, then a plus, then a fraction line. In this fraction, we're going to put x plus 3, and in this fraction, we're going to put x plus 5. And then here's the thing is put letters, okay, basically capital letters, usually A, B, C, etc., in the numerators. All right. So first, we factor the denominator. Then each one of these factors gets its own fraction. And in the numerator, we're going to put letters. So we're going to put an A up here, and we're going to put a B here. Okay? So let's say that you had 7 over x minus 4 times x plus 10. Pause the video. What would you turn this into? Like this. What would you turn this into? Just pause the video and try it. All right, so yeah, this would become two separate fractions, and you would have a over x minus 4 plus b over x plus 10. Okay, that's step 2 in the partial fraction decomposition. All right, now what we're going to do is this. Now, I'm going to explain why the first time, but I'm only going to explain it why just this one time. All the examples I do in the future, I'm not going to explain this again. Here's what we need to do, and don't hate me for this, okay? But temporarily, we need to actually create a common denominator for these two fractions. If they're being added together, they need a common denominator. You're saying, well, Mr. Ryan, you just said we were going to undo this so that they don't have a common denominator. Yes, I understand, but in order to solve, here's the key. We're now at a point where we need to solve for A and B. And in order to solve for A and B, it's important that we make it so that we got to use this 4 over here. And in order to use this 4 over here, we need common denominator, common denominator, common denominator, so that we can set A plus B equal to 4. But it's not going to be A plus B. You'll see in just a second. So here's the thing. I want you to think about what you just learned about adding rational expressions. If you wanted to add these two rational expressions, wouldn't you need to multiply this one by what's in this denominator over here, right? X plus 5. You'd have to do X plus 5 over X plus 5, right? So X plus 5 over X plus 5, right? And then over here, this one needs an X plus 3. So we're going to multiply by X plus 3 over X plus 3, right? I'm going to put some parentheses in there because we're about to do some multiplying. We're going to leave them in factored form. And here's what you would ultimately have. 4, so now we have 4 over X plus 3 times X plus 5 is equal to, now, what we have here is A times X plus 5, right? Well, let's go ahead and distribute that. So we have AX plus 5A over X plus 5 times X plus 3 plus, now here we're going to distribute the B. We're going to get BX plus 3B over X plus 5 times X plus 3. Okay, now that we have common denominator, common denominator, common denominator, okay, what we can do is, look, it's an equation. What we can now do is we can cancel all of the denominators because they're the same. And so now, if all the denominators are the same, then 4 must be equal to this expression here. Okay, so we're going to cancel the denominators. Basically what we're doing is, the way we're canceling the denominators algebraically is we are multiplying all the, both sides by X plus 5 times X plus 3. So X plus 5 times X plus 3. And if we multiply here, we cancel the denominator, right? If we multiply by what's the same as the denominator, it cancels the denominator. This denominator cancels, and so does this one. And all we have left is 4 equals AX plus 5A plus BX plus 3B. Okay? So, step 3 there was find a, or make the new fractions, make the new fractions have a common denominator. All right? And then step 4, cancel all denominators. Okay? Which we just did. Now, here's what we're going to do next. I know this looks like a mess, but it's okay. Just follow along. We're going to put the AX and the BX together. All we're doing, we're just going to rearrange this. We still have 4 equals. Now, so we're going to have AX, and I'm going to hold off here. I'm going to bring over the BX plus BX. I'm just reorganizing. Now plus 5A plus 3B. Okay? And now watch this. Just on the x's, I'm going to factor out a greatest common factor. It's almost like factoring by grouping, but I'm only going to do it to this one. I'm not going to do it over here. So now I'm going to have 4 is equal to, what's the greatest common factor here? It's an x, right? So I'm going to take an x out. And that's going to leave me with a plus b. Okay? But a better way to write it, instead of x times a plus b, a better way to write it is a plus b times x. Then plus, I'm going to put in parentheses, 5a plus 3b. Now here's the interesting thing. This 4 over here, this 4 is just a number, right? But if it was an algebraic expression, it would have an x in front of it, and it would say x plus 4. Now there actually is an x there, but that x, the coefficient of the x, is a 0, right? So now look at this. We have this, let me do it with color. Hang on, let me do this with color. This a plus bx corresponds to this 0 times x. And this 4, positive 4, corresponds to this 5a plus 3b. So what we can say is, we can say that a plus bx is equal to 0x, or just 0. Okay? Or better yet, we can cancel the x, we can ignore the x and ignore this x because they both have x's, and say that a plus b is equal to 0. So we're going to say that a plus b is equal to 0. Okay? And then lastly, we can say that 5a plus 3b is equal to 4. 5a plus 3b is equal to 4. See, what we're trying to do here is we're trying to find out what a and b are equal to, because we have this fraction. We have this sum of fractions here where we have a over x plus 3 and b over x plus 5. This would be our answer. This would be our answer to the partial fraction decomposition if we knew what a and b are, but we don't. So the reason we're going through all this nonsense here is we're trying to find out what a and b are. And now we know a few things about a and b. We know that if you add a and b together, they're going to equal 0. That must mean that one of them is positive and one of them is negative, and they have the same absolute value. So like negative 7 plus 7 equals 0. 9 plus negative 9 equals 0. Okay, so that's what we're looking for. So we know now that a and b have the same absolute value. One's positive, one's negative. But we also know that 5a plus 3b is equal to 4. So what we can do here is we can solve this. This is a system of equations. So let's solve by elimination, shall we? Let's do this. We have a positive 3b here, right? So why don't we make this a negative 3b? So we can multiply this whole thing by negative 3, and we'll have negative 3a minus 3b is equal to 0, because negative 3 times 0 is 0. And now we can solve it as a system of equations. 5a minus 3a is 2a. The 3b and the negative 3b, they cancel, they eliminate, and 4 plus 0 is 4. So we know that 2a is equal to 4. Divide by 2, and a is equal to 2. So we now know that a is 2. Well, now we can go back up to a plus b equals 0. If a is 2 plus b equals 0, we can subtract 2, and now b is equal to negative 2. So a is 2, b is negative 2. And so, watch this. Our final answer, we'll put a 2 in here, put a negative 2 in here, but instead of putting a negative 2 here, I'm going to put the minus here, negative 2. This is our partial fraction decomposition, and we are now done with this problem. So, 4 over x squared plus 8x plus 15 can be broken apart into two different fractions that are equal to 2 over x plus 3 minus 2 over x plus 5. Okay? All right. I'm going to go ahead and end this video now, and I'm going to do a separate video with another example. That way you can just refer back to that example with some shortcuts if you want to. Okay?